Hi guys. So I promised you real notes, the real number system notes. So here we go. I'm sorry about the shadow. So we took these on 8/21/20. We're going to make this page 1. We have some other page 1s, but we're going to make this page 1. We're really going to focus on rational numbers and irrational numbers today. So rational numbers are going to be your fractions, decimals, percents, your positive and negative numbers, it's going to be whole numbers. Those are positive numbers. It's also going to be your repeating decimals, where they repeating and terminating decimals. Repeating decimals are ones that repeat. They're the ones with the bars over them, okay? So let me give you some examples of these things, okay? So fractions, decimals, percent. We're going to just make it a little bigger. So 5, -2, like 1/2, 1/3, 2/3, 2 1/3. See all those fractions? We could do 0, 1.51. How about 92%? We could put a percent in there. 0.38 repeating. See how it has a bar over there? You guys, the square root of 4, because the square root of 4 is 2. So if you put a square root into your calculator and you get a whole number, that's what we call a perfect square root. We could have a negative, like -81. You could have -2.5, -1.83217 with the 83217 repeating. You could have 12/6. You guys, 12/6 reduces down to 2. It still is that still a good whole number. 9, 72, 4 square roots of 16. Now, an irrational number, an irrational number would be imperfect, square roots. Those are the ones that when you put into your calculator, they become decimals. And something that we call non-repeating decimals. What that means is it's a decimal that goes on forever and ever and ever and never repeats the same pattern. So the biggest irrational number that you guys know of, like the most popular irrational number, is pi. Pi goes on forever and ever and ever and never repeats the same pattern. The square root of 5. Because, you guys, the square root of 5 is between the perfect square of 4 and 9. And there's nothing that you can multiply 5 by to get itself. So, like, you can't get 5 by multiplying 1 times 1, 2 times 2, or 3 times 3. The only way to get 5 is 1 times 5. The square root of 105. Again, imperfect. If you were to put it in your calculator, it would give you a decimal. 11 square roots of 46. -7 square roots of pi. -7 pi. You guys, you can do square roots as well. Just so you know, irrational numbers can be negative, but if they have something irrational, it's irrational. I have 8 pi. We could do the square root of 13. And here's one of those decimals, 1.48701, ... You just have to be careful. This is a non-repeating one. It goes on and on and on. You just have to be careful that you're paying attention that those numbers never repeat, because sometimes they get tricky. Now right here, it says, give an example of a rational number that is not a fraction. So we want something that's not a fraction. So we're going to look over here, but what I don't want to do is I don't want to use any of these numbers. I want to come up with our own. So something here that looks like 9. Can you guys think of something? I'm thinking 6. Maybe the square root of 144, because the square root of 144 is 12. We could do 2. We could do -5. We could do negative square root of 64. We could do 15 over 3, because 15 over 3 gives you 5. So even though it looks like a fraction, it's still a rational number that's not a fraction, because 15 divided by 3 would be 5. Those are the type of things I'm talking about. Okay, so we're going to move down here. So this is an important note. The sum or difference of a rational number and an irrational number. So this box plus this box, or this box minus this box, is an irrational number. So it doesn't matter. If you add a rational number and an irrational number, you're going to get an irrational number. So let's pick something from here and here. So let's pick 5 plus pi. So you have a rational number and an irrational number. It equals an irrational number. How about -2 plus square root of 5? We could do 72 minus the square root of 13. We could do -2 plus 6 square roots of 6. We could do 5 minus 3 square roots of 3. So all of these are irrational numbers. It's a rational plus an irrational, or a rational minus irrational. You guys, so anything from this box and this box. Now we got one more example that we're going to do. So we're going to flip these on the back. And we are going to do example number 2. So the example number 2 is circle all the rational numbers. Well, 3 is rational, so I'm not going to circle that. 4 plus the square root of 2. The square root of 2 is irrational, because the only way you can get 2 is 1 times 2. 1.32178 with dots. It doesn't look like any number repeated, so that's irrational. 1.4, that was in the rational box. The square root of 9. Well, the square root of 9 is 3, so that's rational. Just because you see a square root doesn't mean that it's always going to be irrational. 5 minus the square root of 4. Well, is the square root of 4 irrational? Well, what is the square root of 4? Can you guys think? Did you come up with 2? So it would be 5 minus 2. So that's not irrational, because the square root of 4 is 2. 3 plus pi. Well, pi is irrational. I know this from the front of the sheet, so I'm going to circle that. 31. 1 times 31 is 31. So you can't get 31 any other way. So that's irrational. 8 pi. There's a pi next to it, and a pi makes it irrational. And then 0.78 repeating. Oh, there's a bar over it. It repeats. It's good. So that's irrational and irrational. Everything is a real number. And we can fill in the chart in a little bit. But that is it for today. Thanks, guys.